Hang on. No, I've done it. I'm sure it's totally the snowstorm interfering with something. So this was Satoshi on scaling. This is actually the second public message, I think, ever from Satoshi on the crypto mailing list, where he said a typical transaction should be about 400 bytes. Each transaction has to be broadcast twice. So let's say 1 kilobyte per transaction. Visa processed 37 billion transactions in 2008, 100 million transactions per day. That many transactions would take 100 gigabytes of bandwidth, or the size of 12 DVDs or 2 HD quality movies, or about $18 worth of bandwidth at current prices. If the network were to get that big, it would take several years, and by then sending 2 HD movies over the internet would probably not seem like a big deal. We're there. Sending 2 HD movies over the internet really is not a big deal these days. I watch a couple HD Netflix movies on snowy days when I can't go outside pretty regularly. So, Satoshi was confident that Bitcoin could scale. I'm even more confident than Satoshi because there's something he didn't know. I'm scared to press my buttons now. He said each transaction must be sent over the network twice. And that's not true. There's actually this really cool area of computer science research that I've gotten really excited about called set reconciliation. It's all about synchronizing databases across a network in really efficient ways so that you don't need to send all of the data back and forth. You can just send differences. I've got a little white paper about invertible Bloom lookup tables. I'm actually, as soon as Patrick stops interrupting me and dragging me to events, I will actually get back to working on invertible Bloom lookup tables so that we can have incredibly efficient communication between nodes, and so that every transaction does not have to be sent over the network twice, and we should get a factor of 2 for the amount that we can scale. There have also been a ton of crypto results since 2009 that Satoshi could not have known about because they did not exist yet. So fully homomorphic encryption is really interesting. It's basically being able to store encrypted data up in the cloud and then perform operations on it in such a way that the person who's storing the data has no clue what the data is, even though they're performing useful operations on it. In the context of Bitcoin, this is exciting because, again, if you can validate without knowing anything about what you're validating, that's great for privacy, right? There's related work in non-interactive zero-knowledge proofs, which I got busted. I gave this talk at the Financial Crypto Conference, and I said that non-interactive zero-knowledge proofs were not known in 2009, and a professor raised his hand and said, "You're wrong! Back in 1992, we had anyway. We have practical non-interactive zero-knowledge proofs these days that don't actually take, like a year of CPU time to do. We have these things called snarks, which I don't actually understand. And we don't actually have Smurfs. I just wanted to put a cute picture on my slide. Smurfs are not a thing yet in the crypto world. Yet. I'm sure probably next year there'll be a paper at Financial Crypto. Smurfs for something. So I thought I'd end this talk by talking about what I don't know and what I think is interesting, thinking about how things will go. Will the pseudonymous identity/reputation system be solved? Patrick mentioned identity. I think a lot of problems in the Bitcoin space are problems of identity. Who are you dealing with? Are they trustworthy? Are they running a long con and they'll just run away with everybody's Bitcoins? Are they the CIA with some honeypot website where people can hire people to kill other people, supposedly, all that kind of stuff, right? Those are hard problems. I don't know if they'll be solved or how they'll be solved. The privacy problem, I get bashed a little bit because I say that Bitcoin privacy is complicated. And I think Bitcoin privacy is really complicated. I think it's a hard problem. There's kind of an arms race going on between researchers who try to crack Bitcoin privacy in various ways and researchers who try to improve Bitcoin privacy in various ways. I don't know where that will end up. My best guess is that eventually kind of small, ordinary, everyday Bitcoin transactions will be pretty darn private. Really big transactions will probably be not so private. But I don't know. We'll see. We'll have to see where all of these ideas on improving Bitcoin privacy ends up versus all of the new creative ways researchers have of kind of figuring out what's going on the network. There's a whole area of computer science research about probabilistic algorithms that get the right answer most of the time, but they don't always get the right answer. And that sounds kind of crazy, right? You typically want your computer to give you the right answer all the time. But if the algorithm's a whole lot faster or uses a whole lot less memory, then a probabilistic algorithm can actually work really well. I have a feeling probabilistic mining might be a really good idea. If you can make your miner a whole lot faster by producing hashes that are sometimes, maybe they're not quite right. But they're right often enough, and it's quick enough to check, that might be a really useful thing. I'm thinking probabilistically validating transactions might also be a useful idea as we scale up. We don't need it yet, but I think it's a kind of a good thing to have in our bag of tricks. And then there's another area of computer science research that I haven't even looked at, which are streaming algorithms where you have a fire hose of data coming at you and you can't store it all. So instead, you have these clever algorithms that just deal with it as the stream comes in. I have a feeling that there may be some problems in Bitcoin where streaming algorithms might be really useful. I just don't know where those are yet, but I'll be watching.